Hello viewers, in today's session we are going to discuss one important problem from differentiability of functions, and here we are going to discuss this problem in which we have to examine the differentiability of this function f of x, which is a greatest integer function, that is greatest integer of 2x minus 1, and we have to test the differentiability of this function at x is equal to 3, right? So here what we will do, we'll find out the right hand derivative and the left hand derivative of this function at x is equal to 3, and then we'll see whether the left hand derivative or the right hand derivative, they both exist or not, or they are finite or not. And further we'll see whether both the left hand derivative and the right hand derivatives are equal to each other or not at this point x is equal to 3, right? So let us start. So now let us first quickly see the definition of the right hand derivative and the left hand derivative. Now see, if we have a function, say y is equal to f of x, which is defined in some domain, and if we have a point, say x is equal to a, right? And the right hand derivative of this function f of x is given by this limit, that is limit h tends to 0 f of a plus h minus f of a divided by h. And the left hand derivative is given by this limit, that is limit h tends to 0 f of a minus h minus f of a divided by minus h, right? Now if a function is say said to be differentiable at this point x is equal to a, then the right hand derivative and the left hand derivative both should exist, and they should be finite, right? And moreover, if the derivative of the function f of x, it exists at this point x is equal to a, then the right hand derivative must be equal to the left hand derivative. And in that case we claim that the function f of x is differentiable at this point x is equal to a, and the derivative f prime of a, it exists, right? So here we are given this greatest integer function, and our point a is given as 3, and the function f of x is given as the greatest integer of 2x minus 1. So let us find out the right hand derivative for this function. So here we can now write limit h tends to 0. Now f of a plus h, so we can now write here for a we can write 3, so we have f of 3 plus h minus f of 3, and here we have h. And similarly here we have a limit h tends to 0, and we have f of 3 minus h minus f of 3 divided by minus h. So let us first calculate the right hand derivative. So here we have f of 3 plus h, and here we have f of 3. So let us first calculate f of 3. So f of 3 can be obtained by simply replacing x by 3. So we have greatest integer of 2 times 3 minus 1. So here we have this is 6 minus 1, and this is 5. So the greatest integer of any integer is the integer itself. So here we have simply 5. So here we have now limit h tends to 0. Now f of 3 plus h. So f of 3 plus h can be obtained by replacing this x by 3 plus h. So we have greatest integer of 2 times 3 plus h, and here we have minus 1, and here we have f of 3 as 5, and in the denominator we have h. So now the right hand derivative is equal to limit h tends to 0, and here we have 2 times 3 6 plus 2h minus 1, and that is equal to 6 minus 1 is 5. So here we have 5 plus 2h. So here we have 5 plus 2h, and here we have simply 5, and in the denominator we have h. So now we have to calculate this limit. Now in order to find out the value of this limit, we have to find out the value of this expression, that is greatest integer of 5 plus 2h. Now to calculate the value of this expression, we use this concept that this h is infinitesimally very small, and h is always lie between 0 and 1. So h lies between 0 and 1, and h is positive quantity, and h is infinitesimally very small, right? So when h lies between 0 and 1, then 2h, that is the product of h with 2, it also lies between 0 and 1, because h is very 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 small, right? And if we add 5 throughout, then we have here 5, and here we have 5 plus 2h, and here we have 5 plus 1 6. So this quantity 5 plus 2h, it lies between 5 and 6. So the greatest integer of 5 plus 2h should be equal to 5. So now here we have a limit h tends to 0, 0, and here we have 5 minus 5 over h. Now 5 minus 5 is 0, so this entire expression is now equal to 0, right? So the right hand derivative of this function at this point, that is x is equal to 3, is given by 0. So we can also use this notation, that is f prime, and here we have 3, and here we write a positive sign. So this notation is for the right hand derivative. So the right hand derivative is 0, and here we see that the right hand derivative, it exists and it is finite. So now let us calculate the left hand derivative. So left hand derivative is given by this limit. So here we have limit h tends to 0, and f of 3 minus h can be obtained by replacing x by 3 minus h. So we have greatest integer of 2, and here we have 3 minus h minus 1, and f of 3 is equal to 5, and here we have minus h. So now we can write limit h tends to 0, and here we have 2 times 3 6 minus 2h minus 1, and this is equal to 6 minus 1 is 5, and here we have 2h. So here we have greatest integer of 5 minus 2h minus 5 divided by minus h. So now we have to find out the value of the greatest integer of 5 minus 2h. So for this we have just seen that this quantity h is infinitesimally very small, and h lies between 0 and 1. Right now here we have a negative sign, that is negative 2h. So let us multiply throughout this inequality by minus 1. So we have 0, and the direction of the inequality also get reversed. So we have minus 1, then we have minus h, and here we have 0. So when h lies between 0 and 1, then minus h, it lies between minus 1 and 0. Right? So now if we take 2h, that is minus 2h, then minus 2h also lies between minus 1 and 0. Right? Minus h lies between minus 1 and 0, and minus 2h also lies between minus 1 and 0, and remember h is infinitesimally very small. right? So now if we add throughout 5, then we have minus 1 plus 5, and here we have minus 2h plus 5, and here we have 0 plus 5. So this is 5 minus 1, 4, and here we have 5 minus 2h, and here we have simply 5. So when h lies between 0 and 1, that is minus h lies between minus 1 and 0, then 5 minus 2h, it lies between 4 and 5, right? So 5 minus 2 h is greater than 4, but it is less than 5. So the greatest integer of 5 minus 2h should be equal to 4. So here we'll write 4. So we have now limit h tends to 0, and 4 minus 5 divided by minus h, and this is limit h tends to 0, and 4 minus 5 is minus 1, and here we have minus h. So minus and minus get cancelled, so we have limit h tends to 0, 1 over h. Now when h tends to 0, then 1 over h tends to infinity. That is, this limit is not defined. So we can see that the left hand derivative, it does not exist, or it tends to infinity, or in other words, the left hand derivative is not finite, right? So we see that the right hand derivative, it exists and it is finite and it is equal to 0. But the left hand derivative, that is f prime of 3 minus, it tends to infinity or not defined, right? So therefore we conclude that the right hand derivative is equal to 0, but the left hand derivative is not defined. Hence this function, that is f of x is equal to greatest integer of 2x minus 1, is not differentiable at x is equal to 3.